Hi, everyone. So if you guys saw us earlier during the wiring part 1, it's us again.
Welcome back.
Welcome back. And if not, we'll go ahead and do our quick little intro again. So welcome to part 2. This is going to be more advanced content as opposed to our basics in the last presentation. So I'm Riley. I'm a senior this year. This is my 7th year, and I've been our wiring lead for the past 3 seasons, and once we include this season, this will be my 4th season. Oops.
And I'm Dylan. I was on the team for 5 years, and this is now my, I guess, 7th year with the team now, my 2nd year in a mentoring capacity. I'm a cybersecurity student at the University of Texas at San Antonio. Go Runners. And so I'm super glad to be here.
Awesome.
So one of the first things that we want to talk about on this presentation is not basic, but electricity and circuits, as opposed to kind of the more physical aspect. I want to talk a little bit more about the physics and about the mechanics behind it. And part of the reason for that is because it can be wildly helpful for things like debugging. So you've got 3 key terms as far as what we need for FRC goes. The first is voltage. So voltage can be represented by V or E. It's measured in volts, and it's pressure from a power source that pushes charged electrons through a loop. So your battery pushes electrons through a closed loop of wire. And the force and the pressure that that battery exerts on the electrons that makes them move, which is what generates the energy, or what conveys the energy, is known as voltage and can be measured. Current is represented by I, measured in amps. So, for example, if you have a voltmeter, it measures volts. If you have a ammeter, it measures current. If you have a multimeter, it measures both. And it's measured in amps, and the rate at which electrons flow through a given point is over an amount of time is the current. And then resistance is a measure of the opposition to current flow. So is the water analogy on the next slide, I think? Yes. So if anyone's taken a high school or college level physics class where you go over electronics, I'm sure you'll recognize this analogy. Basically, a circuit is analogous to a water system. So what you would think of it as is your battery would be a water pump. So the voltage is the pressure, the amount, the pounds of pressure that your pump is putting on the water to force it through. Your current is how fast the water is moving at any given point, and that can change point to point. But those 2 things have to work together. For example, if you were standing in a big pipe and water came rushing toward you really fast, but it was only a couple inches of water, you'd be fine. Similarly, if you were standing in a big pipe and there was a lot of water, but it was moving very slow, you would probably also be fine. But if you had a lot of water moving very fast, that's where issues arise if you're standing, in the ocean or something. So just think of it as like your current and your voltage have to go together to figure out how much energy you're putting out for whatever given component you're working on. And then your resistance, in the water analogy, is the size of the pipe. When the pipe got really small, a lot of water had to shove through a very small pipe. In circuits, resistance is determined by the material that electricity is being shoved through, and resistance can be used to dissipate energy, to dissipate voltage, drop voltage. And resistance is how we power our things. That energy that's dissipated then goes into powering all of the things we use on a daily basis. So the next thing I want to talk about is Ohm's Law. And this is where we kind of start to get into why this is all important. And it's called Ohm's Law. And resistance is also measured in a unit called ohms, represented by the Greek omega symbol. I forgot to put that up on the slide. But basically, Ohm's law represents the fundamental connection and ratio between voltage, current, and resistance. So it's V equals IR, and then if you know algebra, you can sub it for those other equations up there. But basically, the three important things to remember is that voltage is determined by the battery type. So if you have a, let's say, a 12-volt battery, the potential difference of the circuit is 12 volts. Resistance is determined by the material of the resistor, your wire, your motor controller, whatever. But current is determined by the draw. And in FRC, one of the things to note is that current actually is somewhat, or not current, resistance can be changed depending on how much power you're setting to your motor, how fast it's running, how much pushback it has, which is why your current draw goes up. And that's what those breakers are for, because if you pull too much current, your battery will have an issue. You can see in the picture also on the slide that you can monitor voltage and current in the FRC driver station box. And the FTA on the field technical advisor, will also have extra info. This is huge. So when we're at competitions, Riley and I will get a bunch of people who come up to our pit because we sort of advertise ourselves as being a team that you can come up to and help with any issues you're having. And we have a lot of people who come up to us and they'll go, hey, we just were on the field.
We had a major brownout.
Yeah, sometimes they don't even call it a brownout because they don't know what it was.
Our robot died on the field.
A robot died, or it started moving really slow and jittery. And if I hear slow and jittery, I know what it is immediately. And I pull up these logs. I will then go and walk to talk to the FTA for them, or I'll take one of them with me to show them what I'm doing. And from those logs, you can figure out when and what in the match pulled a bunch of current that caused there to be an issue. Was your battery undercharged? Did your Rio lose power? Because if you've got zero current on your Rio, then you're going to have obviously like huge issues with that and stuff like that. So understanding that pulling a lot of current can be detrimental to the voltage that your battery is able to give out is imperative to have a good substantial FRC team. And being able to calculate your motor's current draw to make sure, if you do your drivetrain gearing wrong, and a lot of people just slap together a drivetrain, but if you do your drivetrain gearing wrong, they will be able to push you across the field because not only mechanical advantage, but because you might brown out when you start to push against something. So moving on here. The next thing we're going to talk about are fuses and breakers. And after I talk about it, Riley's going to go on the camera and kind of demonstrate them for you. But until then, kind of what I want to talk about with you guys is so the difference between a fuse and a breaker. Again, if we were in an interactive setting, I would go, does anybody know what a fuse is? And then I'd have them explain it to me. But they both do the same thing. They prevent circuits from overloading. So basically, if you pull too much current through a circuit, a lot of bad things can happen. First and foremost, your battery can get drained really, really fast. You can run out of power on the field. Your robot can start jittering. Worst case scenario, if it's like a lot of current,
something starts smoking or catches on fire.
Something starts smoking. The metal inside your wires can melt, literally turn to liquid if your resistance is not high enough.
Things we have seen happen before.
Things we've seen. I've seen robots catch on fire. Very rarely, maybe only once, but it has happened.
2018, Alamo?
2017.
2017, Alamo.
So it's just something to be careful of. And so the breakers can really, really help with that. So on your PDP, or your PDP is what we were talking about last session. So the PDP, again, being the big black component that gives power to all of your wires and such. So Riley will show you that right now.
Sorry about that, y'all. I just need to change around some video settings.
There we go.
Okay. So
again, the PDP.
PDP.
So these here.
Oh,
no, sorry.
Not cooperating.
Those big black things are the breakers. Now, while Riley's kind of pointing those out, the difference between a fuse and a breaker is that fuses, which these aren't, there are fuses on here that we'll show you in a sec, but fuses, when they have too much current through them, they are designed so that the little piece of metal inside either breaks or melts. So obviously, when the wire breaks or melts on the inside, current can't go through anymore. It shuts down the circuit. There's no power going through anymore. And you can actually tell, I'm not sure if you can tell on the camera, but you can look at a fuse, hold it up to a light, and see if the little wire is still connected or not on the inside.
Let me grab a Sharpie. Can you grab me a Sharpie, please?
Yep. Sure.
So, okay, I'm going to take this Sharpie, and I'm going to just draw a line over, oh, no, Court, this is not going to work.
Here's worth a shot.
Yeah. The silver one should work.
Awesome.
Nope.
Well, anyway, there's a wire on the inside that you'll be able to see.
You guys can kind of see that silver line.
Oh, you could see the metal in the fuse. Okay.
So that's the little.
Yeah. So that metal that you see there in the fuse will be broken.
It's usually, there's like a little black puff, a little black mark inside of it.
So when you.
And that means it's not working anymore.
Yes. So when you blow a fuse, you know, when you blow a fuse, you have to replace the fuse in order for it to continue working. It's a fail-safe, but it also means that it breaks. So the reason we don't use fuses on the main spots on the PDP is the same reason we don't use fuses in your house. So in your house, your what they call a circuit box or a fuse box is actually what's called breakers. And the difference between a breaker is, while a breaker will disconnect the circuit just like a fuse, it won't break itself. It'll reset after a certain amount of time, or you can manually reset it. So it will only shut down for a period of time based on the current drawn. So you can see here that what we were talking about earlier in the earlier session, you got these 40 amp and these 30 or 20 amp here. So obviously amp is again current. So if these here output more than 40 amps, if more than 40 amps tries to be drawn, the breaker will shut down the circuit.
So here's a 40 amp breaker. You can see that they're significantly larger. And you can get these fuses, you'll get them in your kit of parts, and you can also purchase them on the
I believe it's Across the Road Electronics.
Is that
website,
where it is
but
now?
I'm not positive.
If you Google
FRC
breakers, you can purchase these. But kind of here's your difference. And then 20 and 30 amp look identical. One just says 20 and one says 30.
But and you can determine which type of fuse to use based on how much load you're expecting on your motor, which is something we'll talk about how to calculate later. But it's incredibly important. For example, you do not want to hook your drivetrain up to a 30 amp breaker. It wants to be 40. But also, you probably don't want to hook your intake up to a 40 amp breaker because that's a waste of power. Again, amps are determined by the motor because the motor is the resistor. So
another example, I've got a limelight plugged in right here. So this actually does not get plugged into the VRM. This wire goes straight into your PDP. You're going to want a 20 amp. I believe the website actually calls for a 5 amp breaker, but I don't know.
The recording has stopped.
But we don't use that. So this is a 20 amp breaker plugged in right here. And then I have a motor controller on a 30 amp breaker, and then the other two motor controllers on 40 amp breakers.
Yep. And so with that, again, because amps are pulled and they're drawn by the motor, having a breaker that's too high won't do you any damage, because if you never hit that amount of current being drawn, it's not a problem. Having a breaker that's too low, if you go past it, you won't be able to do what you need to do. So with that said, let's see, where do we move on to now? Oh, the other thing about breakers that I want to go over just really quick is that these breakers, while they are self-resetting, are not instant. So you can still draw too much current through your motors, especially if you're stalling them, so running them to the point where they can't spin anymore. They will pull crazy amounts of current, like up to 200 amps, even though it's a 40 amp breaker, because the breaker takes just a split second to shut down the power. So there's still the ability to pull too much. You have to really be careful not to stall motors. That is the #1 reason that I see why robots die on the field, is because of a stalled motor or bad wiring, one or the other. Okay, so next we're going to talk about, and this gets in a little bit into the programming, but I just want to make sure that we cover it, is the electronics and firmware updates. So all of these different components require updates. So your rubber reel, all of your motor controllers, your PDP, PCM, radio, any independent electronics you're doing. Typically, updates will come out at least once a year, usually around the beginning of the season. But I always tell my programmers who are working on the team, for your safest bet, always check for updates on all of your components at the beginning of the season and before every competition.
As a general rule, anything that needs data or that data will be passing through will need firmware updates. So, I mean, if you're going to go with anything independent and you're not sure, if data is going to pass through it at all, just check and see if it needs a firmware update. There is a ton of, so we linked the firmware update walkthroughs from individual kind of companies or from FIRST here. Those QR codes, again, please feel free to scan them, but this will be uploaded to the resources page on the Bronc Botz website. But there is pretty thorough walkthroughs for pretty much anything that is going to need a firmware update if you can find it, which it was not difficult to find any of what we were finding.
Additionally, if you forget to update something, typically you'll fail inspection at competition, and then they'll call over what's called a CSA, Control System Advisor, someone who walks around the pits to help you with any wiring or programming issues you have. And they have all the latest software on a flash drive. They can update it for you. The reason you want to do it yourself is because by waiting for the CSA, you are losing time at the competition because you're not inspecting. That's less time you spend on the practice field, less time you spend getting your robot ready, less time getting your people in place. If it's all ready by the time you get to the competition, you are faster through inspection.
And you can do a little bit more last minute work and practice and stuff like that.
But you shouldn't have to do last minute work because that's bad. Okay. Next, in addition to firmware, the RoboRio image gets a new image every single year.
So it's firmware versus software.
Yeah. So different. This is almost like the operating system of the RoboRio. You just have to remember to update that. And so we have that QR code there as well, which will be up on our website. So I just wanted to inform you all about that. Those updates can cause huge issues if you don't install them. You get to competition, you don't catch it, inspector doesn't catch it, then you get on the field and something doesn't communicate with something else.
I am just going to reiterate, the RoboRio needs a firmware update and a software update.
Yeah.
2 different updates, not just one. Everything else only needs one. The RoboRio needs 2.
They are done through the same client,
right?
Which is nice.
But
the RoboRio updater comes in your kit of parts.
Also keep in mind, it has happened before. It's extremely rare when the new image is released. You need to keep an eye out on Chief Delphi or on social media, because if that released image has a problem, you will need to re-image your Rio again.
But again, the inspectors should be checking for all of that at competition. All right, so now Riley is going to talk about, from a wiring perspective, the differences between different types of motor.
So I only have one motor on here right now. This is a 775, but we're actually not going to start with that. I want to start with, I have kind of 2 different categories of motors. You think of a drivetrain motor, which is going to be, the size of your forearm and quite heavy. And those are going to be things like your Sim, Mini Sim, your Neo, and your Falcon. A couple of those are listed kind of right in this little top corner. And then you have kind of mechanism motors, the new Neo 550, or your bag motor, kind of more FTC sized, almost in my mind, is going to be things like your Anti-Mark Never Rest or your Redline. And then our favorite and kind of one of the most common ones that I see is 775 Pro, which is what I see right here. I do want to point out that for the 775, it has this wire back right here. Where are my snips?
And while she's doing that, can I just confirm from someone else on our Zoom call that we are still connected? Just because we're having some Wi-Fi issues over here. Okay, awesome. Just wanted to make sure.
So you'll notice that kind of right on the back here, there's this little black cover. I'm going to go ahead and remove the tape that's on here. Now this is, what is it called?
A 775 Connect.
There you go. And what this basically is instead of soldering leads onto your motor, it's a little cover that sits on the back of your motor and redirects your wires in 180 degrees. This is brand new. This is something not seen before, what, last season or the season before?
Season before.
And I find that these are extremely helpful. You're going to see a lot less wire damage to your leads. And it's also can just be convenient to redirect your wires 180 degrees. I really do like these. We use these on our shooter last year. I took this straight off of our shooter, and we found it really convenient to have this and not have to worry about wires sticking out or any funky leads or anything like that. So other than that, I wanted to go ahead and move on to the JVN calculator. So let me go ahead and share my screen again. There you go. Okay, so JVN calculator, the JVN calculator is kind of the original calculator, but it is not the only one. This is a calculator that focuses specifically on the torque and power draw for your motor. So you'll see a little diagram over here on the side.
It's just a spreadsheet.
It's just a spreadsheet. It's an Excel spreadsheet that helps you calculate what your drivetrain or mechanism is going to look like based off of what motors and how many and your gear ratios and things like that. A lot of teams don't use this. You should, because you can use different gear ratios. You can utilize and see your data on several different gear ratios to figure out what's going to be your ideal ratio of power draw to torque and power, so that you're not drawing too much power and you're not too weak.
Now, obviously, this is a very mechanical-based tool. You know, in your design workshops, I would hope at least that they'd be going over this. But the reason that I talk about this is because a lot of people will use the JVN calculator to say, okay, with this gear ratio, we can get this speed and this torque, right? So the amount of force that we can push against and the speed we can go, and the only way between those two, and they won't look at, I think it's in the bottom right-hand corner in that photo, the amps that their stall current pulls. And you can look up on Chief Delphi the best kind of ratio to have with that. But basically, if your amps are off, wildly off, you will brown out your robot. And this is a way to tell that. And browning out, by the way, is just pulling too much power and killing your battery. Not killing your battery, but draining it very low. Lower than, I believe, 7 volts is considered a brownout, which is when,
it's more than that.
It might be 8, which is when the radio goes into protection mode and basically shuts off your robot. And then has to restart, which is never fun.
Now, JVN is no longer releasing JVN calculators.
Correct.
So his last release was in 2017.
JVN is one of the head mentors for 148 Robo Wranglers, if you didn't know.
Right. So all of the things that you're going to see on JVN calculator are going to be 2017 and before. That means no Neos, no Falcons. That being said, you can do that math and enter that data yourself. That is possible. If you are interested in that, please feel free to email us. We're not going to go over that here, but there is also other versions. I linked Robototes. That's that second, that lower QR code and that lower link. They have a newer JVN calculator spinoff that does include a lot of the newer components.
Yep. All right. And then obviously that can tell you your stall current and stuff like that, which is very, very helpful for understanding what the load on your robot's going to be. And you have to determine it based off of which motors are going to be running at the same time on your robots. Like obviously the stall current on all your motors would be way too much, but you're never going to run all your motors at the same time.
Awesome. Okay, so now we're going to go ahead and hit external accessories on your robot. So, all All right, cameras. A lot of the idea behind cameras, it's going to change year to year. So for anyone who was involved in 2019, we had drive cams, which are literally just cameras that connect to your driver station so that you can see what's happening from the robot perspective. Other teams will use things like Limelight, or some teams will even use custom vision software, but that helps your accuracy in shooting. So it just kind of depends on what you want. One of the most common, most popular is a Limelight. That's actually on our board. That's what I've been showing you guys a couple times over this day. They're all wired a little bit differently. They're all going to have wiring diagrams, or at least any that are FRC, commonly used in FRC, are going to have some kind of wiring diagram somewhere on Chief Delphi or on their website.
But chances are, the Limelight being the exception, that they'll be powered through the VRM, because they will take a lower voltage power. So now that we've talked about voltage, interesting thing to note is while the PDB steps down on current limit, it's still all 12 volts. The VRM has a circuit inside it that actually reduces the voltage being given out altogether. Bronc brings it down to either 5 or 0.5 volts for smaller things that you're doing, like LEDs. You try to put 12 volts into an LED, it's not going to end well for you.
Okay, so that's cameras. You can use anything that's within FIRST guidelines, and that's all released in the game manual. So the other thing is coprocessors. This is a lot going to kind of focus and rely on programming, in that the programmers are the ones who are going to be using this stuff most likely, because any coprocessor that's on your robot would likely be for some kind of vision software. We in the past have used a Latte Panda because it runs Windows, but there's Raspberry Pis, an NVIDIA Jetson Nano. Any small kind of handheld coprocessors would work. Yeah. Again, just do your research and figure out what is kind of more widely used in FRC, because the more widely used things are going to have more online resources that you can reference.
So really the whole point of that in this session is just be aware they exist. If you need it, you will probably know, because your programmers will probably tell you. But just be aware that it may be an extra consideration in the wiring. So now we're going to move on to sensors. So there's a number of different sensors. This is just a few. Most, if not all of these, wire into the analog or digital ports on the RoboRio or the PWM. So all into the RoboRio.
I'm just going to go over analog versus digital again. DIO, your digital ports, there's 10 of those. They're on one side. Those are going to be if it returns 1 or 0. So a limit switch or something like that, versus your analog in, your AIO ports are going to be something that returns anything between 0 and 1. So a potentiometer or an encoder, and kind of we'll go over why those do what.
Mm-hmm. So. And the other thing is, so you've got proximity switches, which are typically, you have mechanical, so limit switches on, off, something you can hit. You've got your magnetic or photoelectric proximity switches, which can usually tell you, if something's very close to them. Then you've got your distance sensors. So LiDAR, which is laser detection. Don't know a lot of teams that use that, but I do know that, 4-time world champion, I think, 254 Cheesy-Poofs uses LiDAR on their robot. That's about my extent of knowledge about LiDAR. Ultrasonic sensors use sound waves to detect, potential obstacles in your way or things in front of you. Shaft rotation sensors, these you should see all over your robot. Some motors, like the Falcon and Vinios, even have these built in. So encoders and potentiometers, those can count the number of times or the amount that your motor has turned its output shaft, which can then be very helpful for programming and counting, stuff like that. And those are typically wired either into the AIO or into the PWM, along with accelerometers and gyroscopes. What I'm going to do is I'm going to turn off the slide just for a sec. Something I want to point out. So when I said accelerometer, gyroscope, compass, all that kind of stuff, this purple board we have here is made by Koei Labs. It's called the NavX. It can sit on top of your Rio. And basically it has a bunch of different sensors inside it. So if you're looking to get started with sensors, it's a great way. It's easy for programming and it's easy for wiring. You stick it into the serial port that's right underneath this right here.
And screw it on.
And then screw it on and you're done. No wires necessary. And it interfaces directly with it. So I would highly recommend the NavX, the phenomenal product. And I just wanted to bring that up to show you that that's an option when it comes to sensors that have easy wiring, no cables needed.
The other thing that I want to point out that is also kind of a newer addition to FRC, you'll notice that on my 775 right here, you'll notice that I have a stack here. This stack is actually one gearbox, and it's a 3-to-1. And then this second stack that you see here, you can kind of see the reflection. The second stack is actually plastic, and it is actually a mag encoder that sits inside of your stack. So it's a very easy internal encoder that you can easily put onto a 775. You don't even need a gear down kind of stack here. You could literally just stick this onto your motor.
Yep, and that can help with, but you have to use a Talon SRX motor controller with it.
Yes.
That's the only thing that has the ribbon cable connector.
Which is right here.
Yeah, that right there. And that's all documented online as well. So if we go back to sharing slides, next up.
Wire management, that's my
so
section.
Riley, you take it away.
All right. I do want to point out this board, one, has been put together in the last couple of days, and two, will likely be taken apart shortly. So you'll see that there are a couple of messy spots. If I were to actually manage this board, I would put a couple of extra zip ties here, and just extra zip ties to help clean stuff up. I did not do that here because it would be a waste of material. And I'm running low on zip ties. This looks like a lot, but that will not last all that long. So just keep in mind that this is messy. This is messy. So why? There's a couple things that are 100. Well, there's one thing that is 100% necessary. Zip ties. Zip ties are your best friend. You'll see them everywhere. You can do anything with them. You'll notice I have loops here. I have them connected down to things. There's more loops, more loops, connecting bunches of wires, like right down here, connecting connecting bunches of wires, connecting a bunch of wires right down here, connecting two wire ends here where I have this Anderson, especially if this was in a high impact place, I would put a zip tie right through here and zip tie this, because that would make it more difficult to remove. So zip ties are your best friend when you're trying to manage wires, period, end of story, no questions asked. There's a couple of other things. This is we call them wire management pads. They're basically just little adhesive pads that have a little slot. So you can stick this anywhere, and you can zip tie wires to it. So it's basically just a way for you to make your own little zip tie attachment point on anything for anything. Let me go ahead and share my screen again.
One thing I'd like to add is, because I don't think it's in the presentation, is a lot of components like the Rio or the PDP will come with bolts to bolt it down to your robot, or screws. I personally, with our team, and Riley and I learned this, we went to a wiring workshop back in, I went to one back in 2016, where they said this, is don't screw down anything. Zip tie everything down. Everything you see on this board is zip tied to the board. Drill holes in your metal or in your Lexan and zip tie it down, or use those little pads, because for removing in super fast situations, removing and putting back on is so much easier with zip ties, and they're just as secure.
So there's zip ties here, there's zip ties here. Anywhere where you're going to have a hole to bolt something down, you're going to have a hole to zip tie. Anything and everything will have a way to be zip tied down, except well, I mean, other than your RSL has this fancy little screw on, screw off, and you stick that onto a piece of 2x1. But I recommend zip tying everything, especially something that you are either going to potentially need to replace or move or shift around a lot. So I'm going to like drill this into your minds. Do not physically attach your radio in any way other than zip ties or Velcro, because your radio needs to be flashed, which is basically rewriting the internet's configuration for a competition versus a shop setting. And you're going to need to put this on and off and on and off and on and off and on and off of your robot repeatedly. I promise you it comes off the robot and back onto the robot 100 times during the season. The other thing is things like solenoids. So way back here, I've got my solenoids. This should always be zip tied down, because if you need to add additional pneumatics or anything like that, you're just going to want to be able to take that off and then put it back on. And motor controllers, if your motor controller is starting to have problems or you need to take it off to rewire it or whatever, just zip tie, zip tie, zip tie. Don't screw anything down. You can use Velcro, but that's really a lot more expensive than zip ties. So just keep that in mind.
So we were just asked by Mr. Henry if we 3D print a radio holder. We don't typically do that. Typically what you see here on this board with the 2 zip ties running across like this is actually usually, and then we'll do 1 zip tie up like that. That's usually what we do. However, I do know a lot of teams that have had great success with a radio holder, and a radio holder, if you make it so that it's got like hinges or something, like a door on the front where you can open it up,
that's fine.
That is something that you could actually bolt on, because your radio still comes out really easy.
You really just
so
want,
we personally do not.
You really just want something that you're easily going to be able to remove and reattach, which is, zip ties are nice because they're consumables and they're cheap. So I went over zip ties, I went over wire management pads. Next thing I'm going to go over is what it's called spiral wrap. I only have a small piece here because I am working from home, but essentially this is a big long coil. It comes in a big, really, really big container, and you can just stick this around any bundle of wires and coil this around, and it will keep your wires contained. These are they're quite nice. I like them. The only thing is that if you will need to access those wires, this is a pain because it's not quick to put on and take off. So just keep that in mind. I will say that I was talking about earlier about our 2019 robot where we had a robot snag our elevator wires. This is the coil that I had around that was this. I will say that not a single wire was damaged because the plastic on this actually absorbed all of the damage from another robot pulling on our wires. So I do like this stuff, just not for a lift. For a lift, you're going to use drag chain. I'm going to show this from the side. I can't bend it this way, but I can bend it this way. So this would be good for if you've got a lift, you know, your wires are kind of down in this configuration. Then as your elevator goes up, it kind of does one of these. This is what a lot of bigger teams use for their lift wiring. You just have all your wires in this. This is actually a pretty small version. I believe we had this for FTC, but you can get quite big,
like
wider and thicker this way as well. And these are quite useful for lifts. The only other kind of couple of things that I'm going to say is the label maker. I talked a little bit about that earlier, but label maker, when you start to wire anything, you're going to want a label on both ends of your wire. Each wire. So if you know, let's just pull any wire. So you see I've got this is labeled 13. This is motor 13. There's a label right here that says 13. There's a label right here that says 13. that goes to motor 13. You just want everything to stay organized. And then usually somewhere in your pit, you're going to want a chart that says, hey, motor controller 13 or motor controller 13 goes to motor 13 that goes to this function that, you know, is our lift motor or is our intake motor or whatever. And then Dylan was talking about hot glue. You have to be very careful with hot glue. I specifically only use hot glue on the radio. Hot glue can come off, but it's more of a permanent thing until just be careful where you're putting hot glue. You don't really want it anywhere where there's going to be like exposed wire.
We typically have only ever used it in my memory on Ethernet ports and barrel connectors.
So the only other thing I'm going to talk about is Andersons. Andersons are here. If you haven't heard of Andersons, please do research on them. They are the universal wire connector. They come apart, they plug back in together. The cool thing about them is that you can take bunches and you can stack them. So we used to have huge bundles of Andersons on our robots. And even when it's like this, you can still plug in another Anderson to them. So Andersons are really awesome. They can get a little pricey, but they're 100% worth the purchase.
Yep. And you put them on the end of your wires yourselves. And so you buy the little metal contacts that are on the inside and then the plastic things on the outside. It comes in one kit. And then you use a little crimper tool, and then I think you can get at Home Depot. It looks like this.
Yep.
And then you can put them on completely yourself. You don't have to buy any fancy wires or anything like
that.
The
nicest thing is that you can put a zip tie around it that makes it almost impossible to pull them apart.
Yep.
So kind of the last thing that we want to cover really quickly here is going to be so I went over Andersons a little bit. I love these things. Please look into them because they're super useful for FTC or FRC. We use them all the time. Last thing is debugging. This is almost more of a learned thing. We can go over some of the steps that come with it that we recommend that you do, but it is something that you kind of need to just do yourself and learn how to do.
So I see it all the time when I either in our own pit or when I walk into a different team's pit and somebody goes, we're having this issue and here's the problem, but here's why we can't fix it, you know, and they'll immediately jump to a conclusion of like, I want to do this to fix it. I want to do this to fix it. I want to do this to fix it. And they end up, even though they're working potentially faster than other people might be, they end up losing time. If you follow this process that we have on the screen, it's incredibly more efficient. So for example, you need to analyze the issue and then determine possible causes. And you need to fully think through those causes before you test anything. And then get to a point, or before you try to fix it, that is. When you get to a point where you feel like you can fix it, then do it. But if you just try to go fixing things, you may break other things in the process. And then if you're not sure what the issue is, but you have a couple of ideas, figure out a way to test those ideas before you fix it. So one easy way to come up with ideas like that, if something isn't running at all or is being finicky, is signal lights. So the Rio, the PDB, the PCM, all of the motor controllers, the radio, the RSL, the Limelight, all have signal lights, along with the driver station on your computer. So signal lights are your friend. And here's where I have a personal belief that every programmer should also know wiring like the back of their hand. Because when you have an issue at a competition, it is a 50-50 toss-up as to whether it's a programming issue or a wiring issue. And a lot of times you can't tell the difference. So you need to be able to have programmers and wiring people working hand in hand, talking the same lingo, and both of them understanding it in order to communicate with each other, because wiring will blame it on programming and programming will blame it on wiring.
We do this a lot. This is true facts, true story.
And if you have an option or an opinion on why you think it's broken, think through it logically before you touch the robot. If you're a mentor, I would encourage you that if you're a mentor and you're standing in the pit and you feel like somebody's about to do something to the robot that potentially they didn't think through, I always tell them no. I will straight up tell them, hang on, talk to me about this and walk me through every step and explain it to me before you do it. Because a lot of times for them to go through it verbally with somebody, they will realize issues that they're having. The other thing is that multimeters are your friend. So measuring voltage, and amps at a certain point. And you can look up how to use a multimeter really easily. But basically, just take the terminals and put them wherever you're measuring. That can be very helpful for determining if current is flowing at any given point. So those are all my debugging tips and tricks. If you're in the shop, you can also just email us and we'll give you a hand.
Yeah. I know that we only have a couple of minutes left. I just want to see if there's any questions that anyone has before we go ahead and hop off here.
We currently do not have any questions in the chat, but there's been a lot of great information.
Well, thank you. So once again, for anybody who didn't get it earlier, or maybe wasn't here earlier, we can put up, so this is our resources QR code to the resources page on the Bronc Botz website. After a little while tonight, we will get that, or this presentation put up there. So you can take a picture of that. Also, it's just broncbotz.org/FRC resources. So I'll give you just a quick moment to take a picture of that if you need to.
Alrighty. And then other than that, this is our contact information, our nice official Bronc Botz emails. So please go ahead and feel free to email us. I am constantly checking my email, and I know that Dylan is too. And we, if we can't answer your question, we can find a Chief Delphi post that can. So, yeah.
All right, well, Bronc Botz, thanks for your help, and apologies again for session 1 for the internet problems we had.
Okay.
Something about a tornado watch really does not work well with high-speed internet. So with that, everyone, thank you, Bronc Botz, for stepping up and giving the presentation, the 2-part presentation today. For those that missed it, please check the First RGV YouTube channel, and it will be up there for everyone to take advantage of. With that, we'll close out, and we will get the next session started promptly at 3 o'clock. See you soon. This concludes this session. If you're watching us live, please take the time to go back to YouTube and pick up our next session, or you can always visit our live page at firstrgv.me/live and pick up